because our test on Chapter 7 will be next week, Tuesday. We have to be well prepared.
What day did you say, Miss Rumsey? Could you repeat that?
Next week, Tuesday, like 1 week from today.
Could you write that up there just in the corner?
I will in a minute, yeah.
Okay.
So, our test next Tuesday, over all of Chapter 7, and then we have our review for the midterm, and then we have our midterm, and then we have a little project, and then it will be, thankfully, Thanksgiving break. And I know that we all need a big break because we are getting to the point where we are just not doing very much at all. Like sitting there and not writing down anything while we're having our quick discussion out in the hall. So I just want to make sure that we all remember that we have to keep pushing through here to be able to accomplish this information before next Tuesday. And it might not be very nice, but Boyer and I are not really excited about helping people who are not working during class and giving their best effort. So if you know you are not working during class, don't ask, and we won't worry about it, and then we won't even be unhappy, will we, Boyer?
Nope. And on that note, I am staying after today for about 45 minutes. So
if you need extra help, today would be a great day to get that well in advance of the test
But
next Tuesday.
please use your time wisely in class, because otherwise I'm just cranky.
She does get cranky, and then she lets me know all about it, and I would rather not know about it. So we started, and you don't have to write this down, because you either have already written this down or printed it, with the definition of polynomial functions. And polynomial functions were functions that had exponents that were positive, so we'll squeeze a little positive in there. Positive exponents. So x squared plus x plus 2 was a polynomial function. And it was a special one that we learned about in a previous chapter that we call the quadratic. So that was great. And x to the 5th plus x to the 9th plus x squared is a polynomial function. And x to the 1/3 plus x to the 4th was a polynomial function. All of those are polynomial functions because they have what kind of?
Positive exponents.
Positive exponents. So that's all really we needed to do for polynomial functions. Then we talked about putting something in general form. Or sometimes they call it standard form. But if something was not in general form, for example, this equation right there, x to the 5th plus x to the 9th plus x squared, we could put it in general form by putting it in with the exponents going biggest to smallest. So if I wanted, I could just move those around so that my exponents went from the biggest one to the smallest one. And the biggest one in this case is what? X to the 9th. What would I put next?
X to the 5th.
The 5th. And then finally I'd have my x squared. So this was a polynomial. This is the same polynomial, but now written in general or standard form. So the biggest exponent going down to the smallest exponent. We talked about the degree of our polynomial. And the degree of this polynomial would be what? What is the degree of that polynomial? 9. So the degree equals the biggest exponent. And in this case, the biggest exponent is 9. And that degree then tells us that we have 9 zeros. So that equals the number of zeros, which is also the number of answers we might look for in something. Thank you. And it tells us the number of times our graph would turn is 1 less than, good, it's 1 less than the degrees. So Right now, we're not graphing a lot of those, we're using our calculator, but if we had to check and see if our calculator was right, we could look that over. And we did some foiling, or some magic squares, so we had some terms that were written in factored form, where you'd have like x plus 2 and x plus 3, and they are written in factored form. If we wanted to write that in general form, which we did on some of our assignments, we had two choices. We could either FOIL, or we could use a magic square. If we were, let's slide that up for a second, to use the magic square, even though it's not my favorite, I like to push myself a little bit, try different things. We put the x plus 2 and the x plus 3 on the sides here, and then we fill in our box by multiplying the things that are on each side. So x times x is going to give me what?
X squared.
Thank you. X times 2 is going to give me?
2x.
Ooh, thank you. 3x. And 3 times 2 is? 6. So in general form then, this would be x squared plus, put my 2 and my 3 together, 5x plus 6. So these are exactly the same equations, factored form and general form. You can put them in your calculator in either one of those forms. So regardless of what form they wanted us to use, we could take our calculators and we could go to our y equals, and you don't have to do it because we're still reviewing, but I just want to show you that it works both ways. We can put in x plus 2 and x plus 3, and we can graph that. And it will graph it just like if we had put it in general form. And we could put it in general form. And if we checked it in general form, it should do what? It should overlap. It should be exactly the same graph, right? If we don't have exactly the same graph, then we know we made some kind of mistake because we're trying to have the same thing. So we graph the first one and the second one, and I can only see one graph, which means they overlap. If I had made a mistake in my second one, I would see two graphs, and I'd be like, oh wait, that can't be right, because I have the same thing, but I just wrote two different ways. And then we talked about solving polynomials for their zeros, and we talked about 4 ways to solve, and you just did those in your writing. So the 4 ways that we can solve were graphing, table, factoring, which is not very many people's favorites, but it's Boyer's favorite.
It really is my
And
favorite.
the quadratic formula, which is my favorite.
It's your favorite too, Amelia?
Yeah.
The
Okay,
quadratic?
so we could solve things 4 different ways. And in our writing today, we had the problem. So let's switch this for a minute. On our writing today, we had this problem. K squared equals negative 4k minus 4. And I said, what were the 4 ways to solve it? And you told me the 4 ways that we just wrote down, or we just talked about. And then I said, solve it 2 ways. Well, the first thing I have to do is either move this stuff over there or this thing over here. I looked at it and said, negative, negative, I'm just going to move those on over here. Because I could add 4k and add 4 and get rid of all of my negative signs, and I don't like negative signs because they sometimes trick me. So when I rewrote that, and I want to write it in general or standard form, I'd say that was k squared plus 4k plus 4. You could have said, I just want to move this k squared over here because it's less work. And it will still work, but now I have to worry about negative 1s and things like that. So one way that I could solve that then would be by graphing. So if I went in my calculator, I don't have a k button, so I'm just going to use my x button. Squared plus 4x plus 4. And I'm going to graph it and see what I get. And there is my graph. Okay? And my pixelation is not fabulous. You can trace your function And you're looking for the places where y equals 0, because that's me where it touches this line down here. And I'm looking, and I'm getting close to 0 over here, so I'm at 1.3, I'm 0.87, 0.52, 0.26, and then 0.08, 0.007, oh my goodness. And now I'm going back up again. So somewhere between 0.08 and 0.007, or between, on here, negative 1.7 and negative 1.9, I have 0. If I keep going over here, I'm going to have another 0 somewhere in there. My thought is, as I look at that those are really hard to tell. When they cross right on a line, like right on one of these little hash marks, then it's really easy to tell. But otherwise, graphing is not my favorite because it's really hard to tell sometimes. Okay. Somehow I don't like that graph either. So I could go to the table, and if I'm looking at my table, I'm going to look at the same thing. Where is y equals 0? So if I go up here, I have y equals 0 at negative 2. So that's one of my answers. And that might be a double answer. And the reason I can tell that that's this only root we're going to have, it's going to be the same answer twice, is because as I'm looking up here, I go at smaller, 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 0. Now I'm going bigger, 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 and it doesn't look like it's ever going to end. So I have one root here at negative 2. And if I look at my graph, it kind of looks like maybe I have a root there at negative 2. It's kind of hard to read on this graph. And I can double check that one of my other two ways. So if I factored this, I'd have k and k. And I need two numbers that multiply to give me 4. So what are some choices for numbers that would multiply to give me 4?
Negative 2.
What'd you say?
2 times negative 2 times negative 2.
Negative 2 and negative 2. Positive 2 and positive 2. 4 and 1, etc., etc. I don't need to worry about these negative guys because all my answers are positive, so I can kind of rule out the negatives right off the bat. Which of these answers then is going to multiply to give me 4 here, but add to give me 4 there? 2 and 2. And they're both positive. So what you see is we got the same answer how many times? How many times do I have that? Twice, right? So that's what they call a double root, where I have the same answer 2 times. So we only really have x equals negative 2 as our answer, because remember we switch it out. I could also use the quadratic formula to solve that. It'd be negative b plus or minus, and we're just doing them all so that we've had a quick review of everything we've done so far, over 2a, right? And we can sing the song if we were really so desperate. And if I looked at this, I'd say, okay, well, a is 1, and b is 4, and c is 4, because they're the letters right here. So a, b, and c. And now I'm going to plug them in over here to my equation. So I'd have negative 4 plus and minus the square root of 4 squared, which is 16, minus 4 times 1 times 4, all over 2 times 1. So all I did there was just plug in 4 every place there's a b, 1 every place there's an a, and another 4 for my c down here. When I look at it then, I say, okay, well that's negative 4 plus and minus the square root of 4 squared, which was 16 a minute ago, minus 4 times 1 is 4, 4 times 4 is 16, minus 16 over 2. Well, what is 16 minus 16?
0.
0. So really this guy is gone, right? So I'm left with negative 4 over 2. Negative 4 over 2 is negative 2, which is the same answer we got up here by factoring, and the same answer we got on our table right here. You can see it because there's too big of a thing. So 3 of the ways that we could easily see there's a negative 2. The graphing way was a little bit trickier, you think? Because it was harder to see. All right, questions about that stuff before we move on then?